So this window, this is Plebby. What is Plebby? It's a program that allows you to construct and analyze formal languages. It stands for the Piecewise Local Expression Builder Interpreter. Pleb-E became Plebby because English orthography. So this is the tool. And you can define, we have stuff in the chat already. Oh, all right. Yeah, so you can define symbol sets. And so that's going to be like your basis for how you actually define things. So if I want to say, just like as simple as possible, everything is prefix notation, which might be kind of confusing for some. But so equals A set slash A says A is a variable that represents the symbol A. The slash just means this symbol is a symbol. If I say colon,
sorry to interrupt. Is there any way to make your terminal size a little bit bigger? I'm having a little bit of trouble reading it.
I can go as big
Awesome.
as it will allow.
Thank you. That helps so much.
Cool. I don't know what a good font size is. Never do. Put it up here. Yeah, so if I colon bindings, then that shows me I have two variables. We've got A, which I just defined, and then there's also the universe. The universe is just like every symbol that exists in our current environment. And so if I want to say equals, what do we want to do? Cons. We'll just throw some consonants in there. We might have B, we might have D. What am I missing? K and G. So now we've got consonants, some of them, and a vowel. So our universe has all of these things in it. We can define, what is the word that I'm looking for? Alveolars. Alveolar. Those are going to be our T and our D. And you can also define, you don't just have to like list everything out. So you could say A, C for alveolar consonant is going to be an intersection of alveolar and cons. We use the square brackets, just like in like a feature system. You'd say if it's this and this, you put them in the square brackets. Actually, you don't need the braces around it. Like you could do this. I'm T for temp. Like you could do this, but I recommend not doing that because the square brackets have another meaning that we'll get to later. And so if you leave them just kind of open like this, it can be weird. So we've got A, we've got alveolar consonants, we've got alveolars, we've got consonants, and the universe. Great. So that's how we can define a bunch of symbol sets. You got unions, you've got intersections, and that's it. There's no complement. We don't want complement.
I missed the union syntax. What's the union syntax?
Union syntax is just the curly braces. So if I say equals T, you know, const A, if I show T, it's got everything in it. Right, there is also show in addition to bindings. And here we're at a point where I don't want all these symbols and I don't want all these variables. I could unset cons and then I no longer have cons. I could also just reset. We have this nice blank slate. It's as if I just opened it up for the first time. And now that we know basically about symbol sets, I'm just going to define a few. We can do it on one line. We want A, B, and C, and they're just going to be singletons. And you don't have to do this, but if you don't, then you're typing slashes everywhere. Nobody wants to type slashes everywhere. So let's just define our alphabet. So this says we have A, B, and C, and the universe we're working in is A, B, and C. Cool. Now, what is this? It's the piecewise local expression builder. So we want to be able to build expressions representing piecewise or local constraints. What does that mean? Well, a local constraint is based on containment of a substring. So if you want to say, I want all the words that contain AB, you can say equals AB. The syntax for containment is these angle brackets. You can also use less than and greater than if you are insistent on ASCII syntax. They work just the same. I just like the more mathematically traditional sequence syntax here. So we want to say contains an A, B. And now we have AB is an expression. It doesn't actually show you what the expression was because it's not that smart, but it will tell you there is an expression called AB. And if you want to see it and you understand automata, you can display it, and that'll show you the FSA representing contains an AB. Great. But that's a local expression. We can also do a piecewise expression, which is things occur in order, but not necessarily adjacently. So if instead I say contains A, comma B, the comma means there is potentially a gap here. We get windows overlapping. That's what we get. So here's the local expression. It contains the substring AB. Here's the piecewise expression. It contains the subsequence AB. Now, if we unset, well, we'll just reset. Nah, unset the universe. We'll unset C. Okay? So now we have A and B. We've got AB. Unset universe is kind of hacky. I don't recommend actually doing it, but it gets us back to a point where we are. So I'm going to restore the universe. And we're going to see if that did what I wanted it to do. Yeah, so the universe now is AB because the only things that we really mentioned are A and B.
Can I ask a question?
Yeah, sure.
What would happen if AB, the expression, had involved C in it somewhere? Would restore universe be smart enough to notice that you still needed C?
Yeah.
Okay, cool.
Yeah, so if I define something else like ABC equals the union of AB and doesn't contain a C, I need the slash because I don't have C defined anymore. Now the universe has A, B, and C in it. If I unset the universe, if I can type and then restore it, show universe, it's got A, B, and C.
Cool, thank you.
Yeah, but I actually don't want that. So reset, we'll do it from scratch. A is A, B is B, AB is going to be contains AB, and I actually need to remember what my syntax is. So colon help, we get this nice screen full of all of the commands, and colon equal is the one that I was looking for. So you can say colon equals A B, so the local contains AB versus the piecewise contains AB. And it'll say in the current universe, which is just AB, they are the same. But if we add C in there, now they are different. So the interpretation is always with respect to the current universe. But the expressions preserve their meaning, like regardless. So if I unset C, unset universe, restore universe, we're going to say equals AB, the same. We'll call it local AB, equals PAB, piecewise AB. That is not a B, that is a D, that is a B. So now we have lab and we have PAB. We can display lab, and that's going to say, we'll only have the two of them. We'll display PAB. So they look the same. But now if I add the C back in, like you can see that they didn't just store the automaton of the expression. I mean, they sort of did underlyingly, it's all automata, but the automata are augmented with basically a question mark symbol that says if you see something that's not in the current alphabet of the automaton, where's that going to go? So you can maintain the semantics of this as a local constraint versus this is a piecewise constraint. And I think that's like one of the biggest features of this tool is you can define like generic constraints to say this semantically has this meaning. And so then in whatever context I put it, it's going to mean that thing, no matter what the surrounding alphabet is. So you don't have to define all the symbols you care about in advance. You can just have kind of like a generic library of constraints. And that's fun. But you can also classify them. You can see at the top of the terminal here, there's determine if expression is definable in all these sorts of ways. So, you know, for our contains AB, remember C is in the universe now, so this is not strictly piecewise, but if the universe were AB, then it would be because, wow, need a compliment. Strictly piecewise is a conjunction of negative literals, and a positive there just isn't going to do it. So we have this hierarchy of constraints classes over here on the left is why I've got this window open. It's actually a lot bigger than this. The whole thing, projects, Lambert toolkit 2 dot PDF. I think it's called hierarchy dot. So this is the full thing. 2.9, there we go. So these are all of the classes that it knows how to deal with. It's kind of a lot. There's also some that are missing. So like whatever, just test the complement. That's fine. That's too much. So I just want to talk about these guys. So you can ask if something is finite. That's a nice simple check. Contains AB is definitely not finite because there are infinitely many things that contain AB. But the word AB, you might want to specify just that. We have the anchor symbols. And like I said before, everything is prefix. So anchors go to the left side of the expression. But so this is the fully anchored factor AB. And that is finite. It's a single word. What happens if we display it? It is just the word AB. You You can also remove a fish. It starts with AB. You can remove the other fish. It ends with AB. That one's a little more complicated looking. You have more states there. And some of you might not want to type the fish. So left fish is %bar. Right fish is bar%. They kind of resemble the fish. And it works out just the same. This is all documented. I have a man page. It has the basic syntax. Nobody cares. Unicode syntax. So for all of the symbols that are used, there are Unicode equivalents. I tend to write those. You don't have to. So anytime I type a Unicode symbol, whichever one it looks like, there's the ASCII equivalent in the documentation. Cool. The classification. So we saw finiteness. Is finite word AB? Absolutely it is. And is strictly local? Doesn't contain AB? Absolutely it is. Strictly local is not closed under complement. So if we remove that, then it's not anymore. Great. That's what we expect. But in phonology and phonotactics, sometimes we care about things that only affect like certain symbols and others are transparent. And so you can actually define that also. So you can say, what's my universe right now? A, B, and C? Yeah. So suppose we only care about the consonants, the vowel, the A doesn't matter. So we can say, you know, maybe we want to say we can't have two C's adjacent if we ignore the A's. So like, what would that look like as a regular expression? Not even sure. But as a piecewise local expression, you can say, well, I don't want to have two adjacent C's over the tier BC. If we display that, you know, we ignore the A's. You can have C, but after you have that C, you can't have a C again, unless you see a B. See, the A's, they don't save you.
Wait, can I clarify the semantics of this expression?
Yeah.
So the way to read this is basically you erase everything that's not a B or a C, and then you apply the constraint to that substring or subsequence.
Right.
Okay, cool.
Yeah. And, you know, we have all of the tools that let you define entire regular expressions, because what's a regular expression is your base is, no, I don't want to start dictation. Your base is like single symbols or words, essentially, and you have the Kleene star and you have union. And we have all those operations. Say union type intersection, everybody goes mad. Yeah, so we can do anything that's regular. But so we have this no adjacencies over the BC tier. Classify that. Is that strictly local? No. Is it strictly piecewise? No. It's what we call tier-based strictly local. That's this class over here, TSL. So for any local class you can think of, anything that's defined by adjacency, there's a tier-based version of it. And we can just say, I have this expression. What is it? But maybe you don't have an expression. Maybe you have a regular expression. Well, you can write that out. That's fine. Maybe you have an automaton. I don't actually know if I have any automata, but I can make one. So I can write ATT this expression to, I'm going to call it ~tsl.att. And symbols, I'm not going to write out the symbol table. If you wanted to, you could, well, we'll go ahead and do it. We'll say alphabet.sims. The other underscore is what you want the output side to be, like if it's a transducer, but they're the same, so you never really need to fill this out because I only deal in acceptors. So we can open up another terminal, tsl.att. This is just a description of this in a portable format that OpenFST and other tools can read and write. So interoperability, great. What did I call it? Alphabet.sims. Like this is the kind of file that you would need to use in OpenFST if you wanted to retain alphabetic symbols. So like you can export to something that these other tools use, and we can, let's reset so we know we've got our clear empty slate. And now we can read att:/tsl.att. And what did that do? It gave me an expression called it, and it populated the universe. So now if I display it, wouldn't you know, it's exactly the same thing. However, automata written out to file in this interoperable way, they don't maintain their semantics anymore. You kind of lose that, but that's to be expected because you just have an automaton. So now if I add D to our universe and display it again, the D didn't go anywhere because it essentially just, it goes to the sync state that is hidden. So rather than having the semantics of you can't have two C's adjacent when you're only looking at E's and C's, you have the semantics of this is the language, the whole language, there is nothing else going on. Sometimes you want that. And I think that's basically the intro to like the set of features. And so I wanted to kind of get a feel for like what kinds of things people might like to try to do with this so that I could go deeper into some other subparts for that. Darcy?
So this may be outside the scope of the talk, but I'm realizing that I'm completely unfamiliar with all of these language classes. And I was wondering, like I've never heard of strictly local before. Is there like a quick definition of it?
There's quick definitions for all of these. So we'll start from the bottom. We'll go up to the top. This is kind of a dumb layout, but it's what Dot gave me. Finite is literally just a list. Cofinite is the complement is just a list. Cool, those are simple. Strictly local means substrings. You got a list of substrings you can't have. So can't contain CC. That's strictly local. Strictly piecewise is a list of subsequences you can't have. Subsequences order but not necessarily adjacent, and that's the comma. Tier-based means you get to ignore some symbols. Co just means the complement of this language is. So must contain a C somewhere followed by another C. Yes, strictly local is SL. SP is strictly piecewise. The problem with the acronyms is there's just too many of them. Locally testable, LT, is the Boolean closure of strictly local. So you can intersect them, you can union them, you can complement them, which means necessarily it also contains co-SL because that is a complement. There is piecewise testable, which contains strictly piecewise and complement of strictly piecewise for the same reason. It's the Boolean closure of those guys. Language theoretically, this means you get to look at the set of substrings or subsequences and make a decision based on that. So you can say if it contains an AB and contains a CD, then it's bad. Threshold testable, that's the other T's in LTT, is you get to count up to some number. But unlike regular, you don't get to do modulo counting. So like 3 plus 1 is not 0, it is 3. That's the whole of this small subset of the classes we can work with. Those are like the most relevant ones to phonological work. We can also combine locality and piecewiseness by sticking commas in the middle of things. So this contains an AB block followed somewhere later by a BC block. And if I display that, it yells at me because I haven't defined my variables. The error messages could use some work. Basically, you see an error message, you know you did something wrong, but you don't know what, because it just kind of gives you every possible error that could possibly be anywhere in this expression. Not a variable. Those are the ones we actually cared about here. But yeah, so it contains an AB block followed somewhere later by a BC block. Cool, that's what we got. Yeah, so there's the brief rundown of the classes, following our brief rundown of the syntax. And John Roski posts in the chat a paper/journal overview of most of these classes here with a whole appendix of language examples. Ah, yes, I forgot we had done that. Yeah, so the JLM paper linked there in the appendix has like actual natural language examples in this syntax so that people can see those and enjoy them. I might have it on here actually. References. Lambert et al. 2021. Yes, here's the appendix. Let's make you more big. And so you can, like, sure, the choice of variable names we've used might be a little weird, sigma with a star over it, but you know, anything that you can type that starts with a letter is a valid variable name. So if you've got a letter and a combining diacritic, it works. Sigma's a letter, so you can have that as your variable name. And yeah, so we've got AB alternation. That's a nice, usually it would be consonant vowel alternation probably, but it's a nice simple syntax for it. And there's a whole bunch more. Well, not that far, that's the references, but you got all sorts of examples there. So if you check out the paper that John linked, you can actually read them.
Quick question. So Plebby can tell you whether something star free. Can it tell you the star height of a? No.
So star free is star height 0. Regular is star height whatever. And I don't have any classes between star free and regular. Actually, do I even have is regular?
Isn't it an open question whether there's any languages that have a star height of more than 2?
I think that there's a construction for a question of star height, anything. Oh, maybe I'm wrong. Never mind.
No, sure. Yeah, I don't even have is regular as a decider, just because the answer is true if you can define it, since everything is underlyingly automata. So above star free, I don't have any deciders. Most of the deciders are built around the syntactic monoid of something, which I don't want to go into what that is, like concretely, but it's an algebraic structure representing the language. So if we say, let's make sure I have all of my symbols, because I don't want random error messages. If we look at the syntactic monoid of contains AB versus the actual finite state, the minimal finite state acceptor, like this can still be used as a finite state acceptor. It's just not minimal in the same way. So most of the decision algorithms are based on doing algebra with this, as opposed to just looking at this. Seeing chat things happening. They're all about star height. Alrighty. So yeah, if anybody knows of a nice algorithm for deciding the star height of a language, I'll gladly incorporate it. This also doesn't give you the factor width of local or piecewise things, even though the Haskell core that this is based on does have that power. So that's trivial future work, is to add a integer display for that sort of thing.
This might be kind of orthogonal to, I guess, the main motivation for the library, which is subregular stuff. But one class of languages that I've been interested in working with is counter languages, where you define constraints in terms of like the counts of various symbols, and you can extend these, these notions of like tier-based and stuff to say, I want to like exclude B's and just like count A's, things like this. So I don't know. It seems like it would obviously it would take you out of the realm of automata, but you could also like extend the syntax in this library to do counter languages.
Yeah, and so like I think handling counter languages in this tool specifically would be a bit difficult because everything is underlyingly built upon automata. But I do have extensions of these same sorts of tools for, like, they're all in different repositories because they're all just like vaguely things that I'm working on. But I've got a one-way transducer version for deterministic machines that will let you do functions. I have a two-way transducer thing that I'm working on that lets you do more fun stuff. I also have a tree library, and the tree library doesn't yet contain classification schemes, but I do plan to eventually get there. And so if your counter languages are definable, or rather if they're amenable to writing, like to translating to a context-free sort of thing, then maybe the tree-based version would be usable. I don't know. Definitely something to think about.
Also a question?
Go for it.
Yes. So how computation expensive are these operations like with large grammars? Because I know like some, like there are these like really industrial finite state toolkits where it's like, oh yeah, we have a transduce with 1 million states and we compose it with something which has 100,000 states and all this sort of stuff. Is this, I mean, some of these are going to be kind of, are they expensive? I mean,
Yeah,
computation.
they're pretty bad. I'm just gonna come right out and say it.
No, no, it's, I mean,
They're not like industrial level stuff. I mean, this tool isn't really optimized for those kinds of things anyway. But like, even if it were optimized, the kinds of things that it does, like the decision problems, are, like I said, they're based on the syntactic monoid. Well, how big is your syntactic monoid?
it can be exponential, can't it? In the
So q to the q, if
Yeah.
q is the number of states, is already the size of the thing that it's actually working with for the decision problems. And the algorithms themselves aren't cheap either. They're polynomial mostly. I think the worst is the tier-based locally threshold testable version, which is like I think it's quintic time.
Mhm.
Might be cubic, but either way, q to the 3q, q to the 5q, both of those are enormous. So you know, it's
Do you have so do you have to go via the syntactic monoid, or are there kind of, I mean, obviously working with the syntactic monoid is like really nice. Are there kind of special cases where you can kind of sidestep that and do the problem directly?
there exist language classes for which there are non-algebraic characterizations, like locally threshold testable, for example. There's recently published, I think in the past couple of years, was a decision problem for that class based on the strongly connected components of like the minimal the minimal acceptor as opposed to the syntactic monoid.
Right,
So that's a huge improvement. I essentially do everything from the monoid just for consistency.
Yeah, that's good software engineering practice, I guess. So.
But for larger things that are like more industrial scale, you would definitely want to use the non-monoidal characterizations whenever possible.
Right.
Finiteness, like there is a monoidal characterization for fin/cofin. I don't actually use that one because is an acyclic graph is just so much faster.
Yeah. Cool, thanks.
Oh yeah, well, like Roski says, if you just throw it on a supercomputer, anything's industrial. But I don't think that's a real solution. Alrighty. Anything else we want to talk about? If not, then I think we're good.
I have a question.
Yeah, sure.
Can you compute the like regular expression derivatives in this framework? So like, I guess these are defined where it's like you have a regular expression and then you say like, if I see an A, what is the regular expression that could follow that A? And there are like algorithms to compute it. Would it be possible in the representation to do that?
So I'll say I don't have any sort of construct a regular expression from a things, but I do know they exist, and that would be something that shouldn't be too hard to add. So Oh yeah, thing that I was gonna mention at the beginning. If this tool looks vaguely almost useful to you, but it's missing a thing that would make it actually useful for you, it's on the GitHub. I think it was linked in the Discord. Go to the GitHub, open up the issues tab, and write me something. Be like, I want this. And if it looks like something that can feasibly be added to the architecture that's here, I will do that. And if it's not, then I will explain why it's not, and maybe we can work something else out.
Someone mentioned checking whether something is star free. Do you want to give an example of that? Maybe just, I don't know, some fun. Who was it that asked about star free stuff?
That was
Somebody asked about
Oh, yeah.
Star-free stuff.
Yeah. Is there a particular star free expression that you want to know about?
BB2.
Now, BB2, what is that? Can you define BB2 for me?
It's the language that was in that paper that we were looking at.
I know what it is. I just don't remember like what it is.
No, I know.
It contains A, and then if this is star free, then I think this is it. It's this, right?
I remember that you had come up with a simpler definition using the tier than what was in the paper.
What is this? It is star free. Is it
TLTT.
O2B? It's O2B. Is it T something? It's TSL.
Yeah, so that's not it, right?
It could be.
Let me see if I can find the paper.
Yeah, find the paper. I was gonna say I could do it over here, but I have so many things open and I'm not sure that.
So this is, if I were to read this in Plebby syntax, this is must contain an A, must contain, followed by any number of sequences of A, B, or subsequences of A, B, followed by a B somewhere, right?
Yeah, if I display it, it looks like that.
Right, okay, even better, all right.
I feel like more people here read state machines than read pleb.
Mm. Mhm.
Colon display is not special or fancy. It just requires that you have GraphViz installed and some program called display. And assuming display does the right thing, it's that. So if you have ImageMagick installed, great. If you're on a Mac, I have a little script. It's fine.
While someone pulls up that BB2, how do you type the mathematical symbols?
So you'll notice I'm in GNU screen. That's what the little bar at the bottom is from that. So if I cat.screenrc, if I hit control space L, it puts me in logic mode. Control space is my command starter. And then if I'm in logic mode, if I type any of these symbols, I get the corresponding math symbol. It's just a thing that I've set up for my own convenience. The ASCII is fine. I fully expect most people will just be using the ASCII. I do really like, so this is BB2. I don't know if it has a fun downward closure, but I do greatly prefer it does not have a fun downward closure. It's just sigma star. How lame. But I do greatly prefer that over the ASCII syntax for the same thing, just because it's so much more clear down. Jeff, have you found BB2 yet?
No, I haven't. I can't even find them. I can't even name the author of the paper. I mean, I know is
Let's
so.
see. Not too many things in here. Where do we mention this? This is discussed in, it's in the algebra thing, right? Line BB2. BB?
I forget, Dakotah, while you're looking for it, is there a way in Plebby for if I give an automaton that's defined in the way that Plebby interprets it? Like, can it come up with the pleb expression for said automaton?
It cannot.
It
That would require factoring.
Right.
And while this does have some factoring capability, it's not to that level. So I don't even remember what the command is. I think it's just factorize. Yeah, so factorize, you can give that. I have an automaton here, right? Yes. So if I say factorize tsl.att, I think I now have a results directory. So this says CC is a forbidden substring. It also says it's not complete because this is the tier-based version, but you know, had I given it the SL version, it would actually factor it. And even still, like, it's not factorize doesn't write pleb syntax because it was written before pleb was written. But so you have basic factoring capabilities. Another thing that I didn't mention, we can see it here in my command list, learn SL, learn SP, learn TSL. There are learners built into this. So if you have something that's strictly local, strictly piecewise, tier-based, strictly local, you can give it some data and you can have it learn them. Positive data, that's it. I could add learners for locally testable, piecewise testable, locally threshold testable. The only reason I haven't is that I'm lazy and those aren't classes that matter for me. So if they matter for you, let me know and I'll add the learners. They're trivial to implement. Where else would this be? It's not in functions. I don't think it's in the ISL paper.
Yeah, I also checked your pleb docs and your other algebra paper.
It should be in the pleb doc, shouldn't it?
I searched for BB2, it didn't come up.
It might be in C2.
Maybe you guys just made it up.
It's just destined not to be.
We'll find it. We'll put it in the Discord.
I do remember, like, there was U2 and there was BB2, and one of them had a really nice tier-based definition.
Yeah, you're right. It might have been U2 actually. I forgot about U2.
Search U2. Yeah, here we go. Yeah, so U2, and I can pull up the actual definition from the literature here in a sec, but it was over the alphabet AB. So let's reset, set A to A, B to B, so I don't have to type slashes. And U2, I've defined as on the AB tier. Well, so let's have C in there. So on the AB tier, you can't have an AA anywhere after a BB block, right? Yes. Well, now I've just defined it. So I now have an it, because if you type a bare expression and you don't assign it to anything, you get it. So if I display it, this is what that expression is. We're gonna get rid of this guy. And then we're gonna go to references, Krebs, K. Just type K. Yes, Krebs. define U2. Here we go. So let's embiggen this quite a lot. And, oh, perfect, it is A, B, and C. So this is the expression that these authors actually give for U2, this language. And so compare that with the same thing in pleb syntax. And see, for some things, it can be much nicer. I feel like this over here is significantly easier to read than that over there.
So now can you tell us where U2 is in these hierarchies?
Yeah. Well, it's definitely FO2 with B. It's FO2. It's not FO2 with successor. And projects language toolkit 2 dot hierarchy dot display. So FO2B is like the highest we can go before hitting star free. FO2B is first order, limited to 2 variables with betweenness. I think you also have general precedence, but you don't have successor. If you have successor, then you're too much. You might be able to define successor with betweenness, actually. You can.
Can you check if U2
Definitely
is,
can.
can you check if U2 is GLPT?
I can. It is. And why is it? Well, because it's TLPT, as evidenced by the expression.
Yep, exactly.
Because it's on a tier, a piecewise local factor. Anything that you can define in this sort of way is going to be TLPT. If you have Boolean combinations of these guys, it'll be in there. But I don't want to do this test because it'll take forever. But it's not TLT. We can try it. So that I said before, like when people were asking about industrial things like LTT and TLTT, the threshold testable case, those are the worst. And so if you were watching, you could see like how long that took on it. Yeah, that's the one. So on a 4-state machine, see if it'll recalculate it. Yeah, it takes a minute. So those tests, you kind of want to avoid those tests if you have the big stuff. But yeah, so we can take these languages from the literature that are like, oh, this is a really complex language. We can say, okay, well, what classes does it fall in? And oh, look, actually, we can define it in a simpler sort of way than having all of these. I think people call it simple soup, even though, you know, there's more operations here. So maybe it's like more complex by that metric, but it's a lot shorter and I feel more readable.
So would Plebby have allowed you to map backwards from this this regex to a like small Plebby expression?
So in some cases, you can use factorize to sort of do that.
Okay.
In other cases, you just kind of have to do it.
Right.
Some things require human intervention, and right now, this is one of those things. I think especially because, you know, for a regular expression, Plebby is all about semantics. So like this is a local thing, this is a piecewise thing. For regular expression, the semantics is this is the language. There's not really any of that sort. So it can actually be ambiguous. Like if your language is AB and you have display contains AB, we actually have C in our alphabet now. But so if your alphabet's ABC and you have this automaton, what would you do if you saw a D? What does it behave like? Does it behave like A? Does it behave like B? Does it behave like C? Is it its own thing? And so the regular expression doesn't really tell you what to do. So to make a pleb expression, it would have to assign a semantics. And maybe it doesn't give the semantics you want. So, it could just say, I want to map this regular expression exactly, map this automaton into the regular expression that it represents. And there's the basic algorithm for that. But I think it was mentioned earlier that we don't really know how to construct a smallest one. Thank you, Jeff, for putting the U2 reference in the chat. I was going to do that. I still am going to do that because library technical bib technical bib grep greps. Cool, there's only one. A is probably fine. Because I have DOIs for everything. Yeah. So that should be a direct link, assuming I formatted it properly, to the paper that came from. And I think that's that. I think it's 2, so our hour is expired. But if there's more that people want to talk about, I'm here, I'm free. People can email me at any time at, I was going to type it in my terminal, but that would be silly because it's not copy pastable. If you want to email me and talk more, email's in the chat there. I don't use my Stony Brook email. I read it, but I don't use it because when I graduate, it's going to die. So the ACM, I'm a lifetime member that will never die. Just mail me there and it'll get to wherever I am. You can also message me on Discord, but whatever. I feel like email is better for these long form sorts of things. Thank you all. And have a nice day.
Thank you.
Okay, thank you. And I'll post the, I'll send the video to Gail and she'll post it on YouTube. So hopefully the people who couldn't make it can see.
Yeah, and if there's anything you'd like for me to post from here, I have stuff. I can put it on the Discord and just remind me what people need.